Welcome back. Before we start our deep dive into today's topic, please take a second to hit that like button, subscribe to the channel, and turn on notifications so you never miss a technical breakdown. It really helps the channel grow. Apache SkyWalking is a powerful, open-source application performance monitoring and observability platform. Originally developed at Huawei, it has evolved into a top-level Apache project. SkyWalking offers full-stack observability by collecting, analyzing, and visualizing traces, metrics, and logs from your services. It's especially powerful in cloud-native environments, supporting Kubernetes, service mesh, and microservices architectures. What sets SkyWalking apart is its ability to unify telemetry data from diverse environments. Whether you're running Java, Go, Node.js, or .NET services, SkyWalking supports them all. It's also native to service mesh platforms like Istio, offering deep insights into mesh traffic. Its modular architecture allows you to extend and customize it based on your needs. SkyWalking comes packed with essential observability features. Distributed tracing helps track requests across microservices. It monitors service and instance health in real time. The topology map visualizes service relationships. And with built-in alarms, you're notified of anomalies instantly. SkyWalking's architecture is composed of 4 major components. Agents instrument your applications to collect telemetry. OAP servers process and analyze this data. A storage backend persists it. And finally, the UI dashboard visualizes everything in a user-friendly manner. SkyWalking agents are the data collectors. They come in language-specific flavors like Java, Go, Node.js, and more. These agents support auto-instrumentation, meaning you don't have to manually trace every function. They're designed for low overhead and support a wide range of plugins for customization. The OAP Backend Servers are the brain of SkyWalking. They process telemetry data, run analysis, and trigger alarms. They also support service mesh telemetry protocols like Istio Mixer and Envoy. With plugin support, you can extend their functionality for custom metrics or integrations. SkyWalking supports multiple storage backends including Elasticsearch, H2, and MySQL. This flexibility allows you to choose based on your infrastructure. The storage is optimized for time series data, ensuring fast queries. Like other components, it's pluggable, so you can integrate custom storage solutions. The SkyWalking UI provides a comprehensive view of your system. It includes a topology map to visualize service relationships, trace inspection tools for deep dives, metric dashboards for performance monitoring, and alarm management to stay on top of issues. Distributed tracing in SkyWalking is based on spans. Each span represents a unit of work, like an API call or database query. SkyWalking correlates these spans across services to show you the full request path. It also breaks down latency by service, helping you pinpoint bottlenecks. SkyWalking excels in service mesh environments. It natively supports Istio and can ingest telemetry from Envoy proxies. This allows it to build a detailed mesh topology map and analyze traffic patterns, latency, and error rates within the mesh. Beyond tracing, SkyWalking collects a rich set of metrics. These include service-level metrics, JVM stats, and system-level information. It integrates with Kubernetes to monitor pods and nodes. You can also define custom metrics for deeper insights. SkyWalking unifies logs with traces and metrics. You can correlate logs with specific traces for faster debugging. It supports structured log ingestion and provides powerful search and filtering capabilities in the UI. This unified view is key to modern observability. SkyWalking's alarm system allows you to define thresholds for metrics and receive alerts via webhooks, email, or integrations like PagerDuty. You can set alarms for response times, error rates, or any custom metric, ensuring proactive issue detection. Setting up SkyWalking involves installing agents on your services, deploying OAP servers, configuring storage, and accessing the UI. While it can be complex, the flexibility it offers makes it worth the effort for production environments. Configuring SkyWalking agents involves choosing between auto and manual instrumentation, setting service names, defining sampling strategies to control data volume, and enabling plugins for extended functionality. Each setting impacts performance and observability depth. Setting up OAP servers requires choosing between standalone and cluster mode, selecting a storage backend, configuring security like TLS, and tuning performance for scale. Proper setup ensures high availability and efficient data processing. For production, Elasticsearch is the recommended storage backend. You'll need to configure indices, retention policies, backups, and scaling strategies. Performance tuning ensures fast queries even with massive telemetry volumes. Once everything is set up, access the SkyWalking UI to explore topology maps, inspect traces, view dashboards, and manage alarms. The intuitive interface makes it easy to navigate even complex telemetry data. To ensure optimal performance, use sampling to reduce data volume, tune storage indexing for faster queries, enable caching and buffering in OAP, and adjust agent settings to minimize overhead. These steps are crucial for large-scale deployments. Securing SkyWalking involves enabling TLS for data in transit, setting up authentication and role-based access control, isolating networks, and enabling audit logs. These practices protect your observability data from unauthorized access. Let's look at a real-world example, an e-commerce platform running on Kubernetes with Istio Service Mesh. SkyWalking provides unified observability by tracing user requests, monitoring service health, and correlating logs for faster troubleshooting. Compared to Jaeger, SkyWalking offers full-stack observability including metrics and logs, while Jaeger focuses primarily on distributed tracing. SkyWalking also has native service mesh support, whereas Jaeger is more focused on being a pure tracing system. Prometheus is a metrics-first system with a pull-based model, while SkyWalking offers both metrics and traces with auto-instrumentation. SkyWalking is more holistic, whereas Prometheus excels in custom metric collection and alerting. SkyWalking is backed by a strong open-source community and is an Apache top-level project. It has an extensive plugin ecosystem, regular releases, and is adopted by many enterprises for production observability. SkyWalking offers advanced features like continuous profiling for performance insights, a meter system for custom metrics, event analysis for operational events, and even AI-powered anomaly detection for proactive monitoring. Continuous profiling in SkyWalking allows you to profile CPU and memory usage without code changes. It provides real-time insights and integrates with traces, so you can correlate performance issues with specific requests. The meter system allows ingestion of custom metrics compatible with Prometheus format. You can define aggregations and labels and visualize them in SkyWalking dashboards for deeper insights into your application behavior. Event analysis tracks operational events like deployments or config changes. It correlates these with metrics and traces to help with root cause analysis. The timeline view makes it easy to understand the impact of events. SkyWalking uses AI for unsupervised anomaly detection. It recognizes patterns in metrics and proactively alerts you to deviations. This integration with the alarm system ensures you're always ahead of potential issues. In Kubernetes, SkyWalking supports auto-discovery of services, sidecar injection for agents, native Kubernetes metrics, and Helm charts for easy deployment. This makes it a natural fit for cloud-native environments. SkyWalking excels in service mesh environments. With native Istio integration and Envoy telemetry support, it provides mesh topology maps and traffic analysis, giving you deep visibility into service interactions. To scale SkyWalking, use horizontal scaling for OAP servers, implement load balancing, shard storage for performance, and tune configurations. These steps ensure it can handle large-scale, high-traffic environments. When troubleshooting SkyWalking, start by checking agent logs for errors, verify backend connectivity, review sampling settings to ensure data is flowing, and monitor resource usage on OAP servers to avoid bottlenecks. To dive deeper into SkyWalking, explore the official documentation, check out the GitHub repository for source code and examples, join community forums for support, and watch YouTube tutorials for hands-on guidance. The SkyWalking Roadmap includes enhanced AI for smarter observability, deeper cloud provider integrations, UI/UX improvements, and support for more programming languages. These developments will make it even more powerful and user-friendly. Apache SkyWalking is a full-stack observability platform that excels in cloud-native and service mesh environments. It's extensible, scalable, and completely open source. Whether you're monitoring microservices or analyzing mesh traffic, SkyWalking has you covered. Thanks for watching this deep dive into Apache SkyWalking. If you found this helpful, smash that like button, subscribe for more DevOps and cloud-native tutorials, and let us know in the comments how you're using SkyWalking in your projects. Don't forget to explore more tutorials and join the community. And that wraps up our explanation. If you found this useful, please hit the like button and share it with a fellow developer. Don't forget to subscribe for more technical tutorials. Thanks for watching, and I'll see you in the next one.